Pumapunku's stone puzzle has confounded science for centuries, but in 2025, AI scanned over 12 terabytes of raw data and revealed something astonishing. A 1,500-year-old code of impossible precision and celestial design hidden in plain sight. If these stones weren't carved but engineered, what did the Tiwanaku really know, and what else are we about to uncover? 12 terabytes of data, gathered stone by stone, became the raw material for a new kind of archaeology. Field engineers crisscrossed the Bolivian Altiplano with laser scanners and drone rigs, recording every surface, fracture, and groove at millimeter fidelity. Each megalith, some weighing over 100 tons, was mapped not just as an object, but as a cloud of millions of spatial points, coordinates locked to the Earth by WGS 84 georeferencing, down to the last fraction of a degree. Drone photogrammetry stitched together thousands of overlapping images, capturing the battered remains of Puma Punku from above and on the ground, aligning each fragment in three-dimensional space. The sheer scale of information outstripped any hope of human memory or intuition. No archaeologist or architect could hold this puzzle in their mind. Patterns vanished in the noise, hidden by centuries of destruction and dispersal, but the machines did not tire. Every angle, every tool mark, every subtle curve was ingested, filtered, and cross-referenced by algorithms designed to see without expectation. In the data labs at UC Berkeley and IDIA, the process was stripped of human bias. The AI worked blind to legend or theory, comparing geometry and chemistry without a story to confirm. It sorted the chaos by pure logic, searching for matches in the silence of the digital twin. For the first time, the stones became witnesses, not mysteries. Their relationships, once scattered and broken, reassembled themselves through the language of mathematics and code. In this new archive, Puma Punku was no longer just a ruin. It was a system waiting to be read. The next step, letting the AI find the logic hidden in the fragments and reveal the secret order beneath the surface. H blocks rise from the earth with a confidence that seems to deny the passage of time. Their forms are not the product of chance or erosion, but of intention. Each angle, each joint, measured and realized with a discipline that resists explanation. Recent AI-driven metrology, working from digital twins of every surviving stone, delivered numbers that startled even the most seasoned researchers. The right angles of these blocks, measured down to the 100th of a degree, hold steady across dozens of fragments. Joints fit so tightly that a blade of grass cannot slip between them, the gaps rarely exceeding a single millimeter. The geometry reveals itself slowly, almost reluctantly, as if the stones are guarding their own secret. Patterns emerge in the data. T-shaped recesses and projecting tongues, mirrored again and again, each slot and tab carved to match its counterpart with uncanny precision. This is not the irregularity of handwork, but the repeatability of a system, an architecture built from standardized parts, not improvisation. At the heart of this system, a different kind of technology appears. Bronze clamps, cast from an alloy of copper, tin, and arsenic, once bridged the gaps between blocks. Their traces remain in the form of shallow rectangular sockets, sometimes still stained green by corrosion. The clamps lock the stones together, distributing the force of earthquakes and binding the platform into a single, resilient mass. Metallurgical analysis confirms the alloy's composition, a deliberate mixture optimized for both strength and resistance to the harsh Andean climate. The paradox is inescapable. These stones were shaped and joined with a precision that, by all accounts, should have been impossible with the tools available 1,500 years ago. There are no chisel marks wandering off course, no evidence of trial and error. Only the mute testimony of geometry and alloy, speaking a language modern engineers recognize but cannot trace to its ancient source. The question grows louder. How did the builders of Puma Punku achieve a level of control over stone that rivals the standards of the machine age? In the sterile light of the laboratory, Fragments from Puma Punku reveal their secrets at a scale invisible to the naked eye. Under the scanning electron microscope, the surface of a broken H-block transforms into a landscape of microbubbles, tiny, round voids caught in a matrix that flows like glass. These are not the scars of weather or tool, but the fingerprints of a chemical reaction. Where natural andesite would show interlocking crystals, these samples display an amorphous binder, a texture more akin to cast stone than volcanic rock. X-ray diffraction deepens the mystery, detecting calcium silicate hydrates, phases that only form through low-temperature reactions, never in the fires of a volcano or the pressure of the Earth. Sodium carbonate, a signature of natron, appears in the elemental spectra, traced in the red sandstone blocks. Its presence is unmistakable, yet no quarry within reach of Tiwanaku yields stone with this chemistry. The grains themselves are uniform, sand-sized, suspended in a matrix that resists classification as natural. When compared against samples from local outcrops, the difference is stark. Quarry stones are coarse, crystalline, and lack the microbubbles and amorphous binding phases seen in the monument's blocks. Not a single trace of the same sodium or binder minerals can be found in the surrounding geology. Lab technicians and spectroscopists cross-check each result, running blind tests and calibrating instruments to rule out error. The data holds. The stones of Puma Punku do not match the earth around them. Instead, their internal structure points to deliberate synthesis. Raw volcanic ash, natron, and water transformed by human hands into an artificial stone. The evidence accumulates grain by grain until the debate is no longer about how the stones were carved, but how they were cast. The story of Puma Punku now hinges on chemistry, not just chisel and hammer. In a controlled laboratory, the ancient recipe was put to the test. Chemists at the Geopolymer Institute gathered volcanic ash from Cerocopia, sodium carbonate from dry lake beds, and water drawn from the high Andean plain. The mixture was simple, but the results were anything but. When cast into block molds and left to cure, the replica stones reach compressive strengths between 15 and 40 megapascals, matching the lower range of Puma Punku's original megaliths. Under the microscope, the new blocks revealed the same uniform microbubbles and amorphous binder textures seen in fragments from the site. Yet the story did not end with mineral chemistry. Analysis of the andesite samples uncovered a quiet anomaly: traces of carbon and nitrogen locked inside the stone. These are not the signatures of volcanic rock, but of organic matter, possible remnants of guano, plant extracts, or carboxylic acids. When the lab team added these organic ingredients to their experimental batches, the mixture softened, flowed, and set just as the legends described. The phrase, passed down through Aymara generations, echoed in the laboratory. The stones flowed like water. Mechanical testing confirmed what the eye could only suspect. The blocks, once cured, rivaled the strength of natural andesite. Their microstructure, too, was nearly indistinguishable from the ancient samples. The path between myth and material was no longer impassable. The process could be reversed, step by step, from digital scan to physical replica, from cultural memory to scientific demonstration. In the words of a Geopolymer Institute researcher recorded in a post-experiment log, history remade, pending next replicate. And in the voice of an Aymara elder recounting the old story, in the time of our fathers' fathers, the stones flowed like rivers. The laboratory evidence and the living memory now walk the same path, each confirming the other. The secret of Puma Punku's creation, once thought lost, was beginning to take shape again, one cast block, one remembered phrase at a time. Inside the digital twin of Puma Punku, the numbers began to whisper a pattern. Block after block, the AI measured and compared, blind to legend and immune to human longing for meaning. Yet again and again, a ratio surfaced. 1.618, the golden ratio, woven through the lengths of H blocks, the widths of gateways, the intervals between platforms. This was not a single flourish, but a recurring signature, appearing so often that even skeptics in the lab paused. The AI, tasked only with mapping geometry, found the same proportion in the distances between ceremonial thresholds, in the heights of doorways, and in the modular spacing of the great stone terraces. The ratio was not imposed by aesthetic theory or wishful thinking. It emerged from the raw data in dimensions that matched to fractions of a millimeter. Alongside these numbers, the reconstructed site revealed lines that stretched beyond the Earth. Sightlines drawn from the main platform, tracked by the AI through the precession-corrected sky of 550 AD, aligned with the rising sun at the winter solstice, the standstill of the moon, and the crossing points of the Milky Way. Doorways and walls, when mapped against the ancient horizon, pointed to moments when the sun or moon would appear to balance on the edge of the world. The plan of the site, viewed from above, echoed the Chicana, the Andean cross, symbol of the three realms: sky, earth, and underworld. These patterns were not the product of random placement. The AI ran thousands of randomized site models, but only the actual arrangement of stones produced such consistent alignments. The geometry of the platform, the intervals between blocks, the angle of each axis, each element seemed to serve both structure and story. The numbers and the sky, the stones and the stars became inseparable. For Dr. Menendez, the archaeoastronomer behind the digital survey, the evidence felt both mathematical and spiritual. The builders of Puma Punku had encoded a cosmic order in stone, folding the golden ratio and the cycles of the heavens into their architecture. The monument was no longer just a feat of engineering. It was a map of the cosmos, a ritual in geometry, a testament to a worldview where mathematics, myth, and the motion of the sky were all one. 19 block types, each one a template, not a one-off, repeat across the ruins of Puma Punku. The AI's clustering algorithms map these forms with clinical detachment, grouping stones by geometry, not by guesswork. H-blocks, T-joints, L-shaped cornerstones, and tongue and groove connectors. The digital taxonomy cataloged them all, revealing an architecture built from interchangeable parts. The same block, rotated or mirrored, could serve as a wall, a step, or a lintel. These weren't the improvisations of a single artisan, but the output of a system. A blueprint logic made manifest in stone. Across the Andes at Machu Picchu, another kind of order emerges. Ashlar masonry there weaves polygonal and trapezoidal blocks into seamless walls, the joints so tight that time itself seems unable to pry them apart. Yet the stones at Machu Picchu, for all their beauty, show no evidence of mass-produced templates. Each block is unique, fitted by hand, its shape dictated by the builder's eye and the rock's resistance. The walls follow a pattern of adaptation, not replication. In Baalbek, the scale grows almost mythic. The Trilithon's megaliths, each more than 800 tons, anchor the site, surrounded by smaller blocks arranged in courses. Laser scans from the German Archaeological Institute have mapped over 200 stones, but the survey finds only isolated instances of repeated forms. The joints are mostly buttressed, the blocks immense but not standardized. No digital signature of modularity links Baalbek to Puma Punku. Göbekli Tepe, older still, stands on a different continent and epoch. Its T-shaped pillars, carved from limestone, share a common silhouette, yet each bears its own carvings and subtle variations. The geometry is consistent, but the AI finds no evidence of a modular system, no family of templates, no plug-and-play assembly. The digital records are clear. Only at Puma Punku does the pattern of repetition reach industrial scale. Here, the logic of the factory appears long before the age of machines. The stones speak in a language of standardization, of parts designed to fit and refit, to be replaced or reused as needed. This is not a tradition seen in neighboring sites, nor in distant megalithic wonders. The global parallels are visual, not structural, echoes, not blueprints. For now, the modular logic of Puma Punku stands alone, inviting questions about lost knowledge, forgotten methods, and the true reach of ancient ingenuity. Shattered blocks lie scattered across the plateau, their fractured faces bearing silent witness to a force that defies easy explanation. Not all damage can be traced to the pickaxe or dynamite of the 19th century. Some stones display a thin, glassy sheen, vitrification, formed only when rock is exposed to temperatures above 1,000 degrees Celsius. The origin of this heat remains a mystery. Was it the work of an ancient catastrophe, a volcanic blast, or something else entirely? To answer these questions, scientists turned to simulation. Using finite element models built from the digital twin, impact physicists recreated the collapse of Pumapunku in virtual space. They tested dozens of scenarios: airburst shockwaves, seismic surges, even the thermal pulse of lightning strikes. The models tracked each block's fall, mapping the direction, angle, and energy required to scatter stones in the pattern seen today. Yet no single scenario accounted for every detail. Some fractures match the violence of modern explosives, others suggest a slower, more chaotic unraveling. The glassy surfaces, rare but undeniable, hint at moments of extreme heat, brief and localized, beyond the reach of ordinary fire. In the laboratory, the search for answers became even more exacting. Thin sections of stone, cut from both vitrified and untouched fragments, passed through the hands of independent analysts. Each sample was coded and sealed, stripped of any identifying marks before being sent to separate facilities. Scanning electron microscopes scanned for glass phases and shock minerals. X-ray diffraction sought evidence of high-temperature transformations. Every result was logged under chain of custody protocols, with timestamps, courier receipts, and intake forms archived for public review. No data was accepted without full transparency. The first round of tests brought more questions than answers. Some samples showed evidence of rapid heating and cooling, but not all. Others revealed only the slow scars of time and weather. The possibility of a single catastrophic blast, whether from the sky or the earth, remains unproven. For now, the stones themselves refuse to settle the debate. What is certain is the rigor of the process. Every claim subjected to blind verification, every anomaly chased down, every step open to scrutiny. In this search for truth, uncertainty is not a weakness, but a sign that science is working as it should, relentless, patient, and honest about what it cannot yet explain. In 2025, AI systems processed over 12 terabytes of scans from Puma Punku, revealing geometric codes, modular planning, and chemical markers that challenge centuries of theory. The evidence shows that the Tiwanaku people engineered 19 standardized block types, used advanced geopolymer casting, and aligned their architecture with the sun, moon, and stars, centuries before similar techniques appeared elsewhere. Yet some questions remain unresolved. The full recipe for their artificial stone, the exact meaning of encoded ratios, and the cause of the site's catastrophic destruction are still under investigation. Ongoing blind laboratory tests and public data releases aim to answer these. What is certain is that Puma Punku was not shaped by accident or guesswork. The results confirm indigenous innovation and technical mastery, rewriting the record of human achievement. The stones stand as proof that there are still secrets beneath our feet, waiting for evidence, not legend, to bring them to light.